And we're live. So this is our second set of notes in Unit 6, Similarity. This is Similarity Dilations. Alright, so a dilation, it's the enlargement. This is the proper word. Or reduction, the other proper word, of a figure. So it's to enlarge or reduce a figure in size, make it bigger or smaller. The scale factor, which y'all learned in the last set of notes, indicates how much the figure will be enlarged or reduced. There is a variable that we use for scale factor, just like we use for a lot of our little formulas and stuff. We always have variables. Midpoint, we use m. Other stuff, we use other variables, you know. For scale factor, the variable that we use is the lowercase letter k. And you can see it down there in your examples. We kind of bolded it too. Those are scale factors at the end of those two examples with k equals and k equals. When k, that scale factor, is less than 1, the dilation is a reduction. Anytime your k is less than 1, you should know that your image is going to get smaller. If k is greater than 1, obviously the dilation is going to be an enlargement, meaning our image is going to get bigger. Alright. Symbolic form. And y'all remember this one when we did it before. You won't see it this first way written a lot, but you have capital T, then parentheses. It'll be k times your x value, and then k times your y value. Let me zoom in a little bit. The form you'll see it as, we'll write it a lot. We'll write capital D, a dilation of k. And whatever scale factor we want to tell you. Alright. So that's the words. Let's actually do some dilations. If you have your ID or whatever straight edge you used to use handy, you might want to get that, because we're going to be on the graph again. Examples. Let me zoom out a little bit. Graph and label each figure and its image under the given dilation. Number 1 says triangle RST with vertices, with a scale factor of 2. So they want us to dilate this triangle by a scale factor of 2. Graph the triangle first. Labeling is important, as always, to get all your points on before you label them. -5, so you don't put your letter in the wrong spot. -5, up 1. -3, up 1, 2, 3, 4. 4. And then 2, -1. So I wait till I get all my points on so I can see how my figure is going to shape, then I'll label. So this is my pre-image, my original triangle right here. And we save y'all space out to the side right here because this is where we want you to do your dilations at. The dilations now, I will say this. These ones that we are doing right now don't specify. But if they don't tell you about any point that you're dilating from, understand that you're doing your dilation from the origin. So this dilation is happening from 0, 0. So I can tell you this about our image. If we make our image larger, the larger we make our image, the further it's going to get away from 0, 0. The smaller we make our image, the closer it's going to get to 0, 0. You'll see on this one, we're going to do an enlargement, so our image is going to get bigger and it's going to move farther away from 0, 0 each point in each direction. You'll see. Alright. And y'all seen me do this before with translations, so we're going to do this for dilations. Out to the side over here, put my points R, S, and T, my originals. Oh my bad, hold on. Sorry, thank you. But I'm putting, I got a lot of space over here. Watch how I do it. I'm gonna say -5 for R. I'm gonna leave a big space in between, and then I'm gonna write 1 on the end. So I'm doing some math on this. Leave some space. S was at -3. Leave a space, comma, 4, and then T was at 2, -1. Leave some space. And if you got a different color, I don't know if you're using pens or not, if you got different color pens, it might be better to do this in different color pens when you see your notes, so you can go back and see what action you took. Y'all know I color code all my stuff, but you don't have to, but I'm just saying. I think it's easier for y'all when y'all go back and look at y'all notes. Just a suggestion. Alright. So the scale factor was 2. Like, this is why I say dilations are easy, because it's really easy what you're going to do. All you're going to do is do some multiplication. The scale factor was 2. I'm literally going to take each and every last one of these points and multiply them by 2. My x and my y value. Times 2, times 2, times 2, times 2. And then I'm going to just do that math, and I can write my new coordinates over here. -5 times 2, -10. 1 times 2 is 2. -3 times 2, -6. 4 times 2, 8. 2 times 2, 4. -1 times 2, -2. That is me doing a dilation. And then I graph. Well, I'll leave that down there for a second if you ain't wrote it down yet. But I'm going to graph those points. -10, 2. -6. That's 8. And then 4, -2. This is me on the graph up here. R prime, S prime, T prime. If you did it right, it should look like this, a dilation, the scale factor of 2. Now, like I told y'all we move our curriculum around, and y'all could tell too, because when y'all took somebody even mentioned it the other day, they was like, the proportions that we learned on Tuesday, that was on the PMA that we took. I told y'all we move our stuff around a little bit. Y'all should have saw dilations on the PMA too, but we moved dilations to this unit for a reason though. This unit is called similarity, right? When you do a dilation, you're creating similar figures. These two figures are similar. That's why it makes sense to teach it right here in this unit. And that's why we do it this way too. It don't make sense to teach it in that transformations unit because you ain't even learned nothing about similar figures yet. But like I said, the other thing I wanted to say too, once again, the larger your image gets, the further it moves away from 0, 0. All my points move further away from 0, 0. R move further to the left. S move further to the left. The T point move further to the right. They all moving away from 0, 0 the larger it get. When we do a reduction, your points are going to get closer to 0, 0. You'll see that on the next problem. Some of y'all probably already went ahead of me, which is fine. Next one, number 2. This triangle, they want us to reduce it by a scale factor of 1/4. Graphing. -4 up. 1, 2, 3, 4, 5, 6, 7, 8. 10, 0. It's way over here, ain't it? Yeah. And then -2, -8. So this was W, X, and Y. So this is my original image, my pre-image right here. I want to reduce this by a scale factor of 1/4. Same thing I did on the last problem. Out to the side here, I'm going to write my original coordinates with space. So W, X, and Y. W is at -4, leave some space, 8. Y is at 10, leave some space, 0. Stop trying to correct me. Alright. What did I say, -10 or something?
Instead of saying X can prove the 10 point, you said Y.
Well, I wrote the right thing, so we'll roll with that. Multiplying by a scale factor of 1/4. 1/4, 1/4, 1/4, 1/4, 1/4, 1/4. Yeah. Look. Don't overcomplicate this. Kids will ask you to years before they always tell me, "Oh, put a 1 under the whole number." All that. That's a waste of time. You should, and I know I did it even in the what's the thing we just did. In the bell ringer, I put a 1 under that. Here, you should know that you're going to multiply the whole number times the numerator right here, and then divide by the denominator. I mean, putting a 1 under here ain't gonna help you. It's still gonna be the same thing. Multiply the whole number times that numerator, then divide by the denominator. Don't overcomplicate this. Alright, every time, no matter what. I don't care if it's 1 over 4, 2 over 3, 3 over 2, whatever. Do that. Multiply the whole number times the numerator, divide by the denominator. Keep it moving. So this is negative 4 times 1 divided by negative 4. Negative 1. Then you got 8 times 1 divided by negative 4. 2. Then you got 10 times 1 divided by 4. Now, and you can have decimals too, because we're not going to write fractions. You might need to do that one in the calculator if you don't know it off the top of your head. So basically it's going to be 10 divided by 4, 2.5. You can graph half a point. Y'all should know how to do that. 0 times 1 divided by 4, obviously 0. And then on the next one is negative 2 times 1 divided by 4. So it's going to be, yeah. I don't know how to turn numbers negative on this calculator. Oh well. Negative 2 divided by 4. Yeah. Negative 0.5. And then negative 8 times 1 divided by 4, negative 2. So these are your points. These are your points you're going to graph. You can graph half points. I should know how to do that. I'm going to show you up here. Y'all got this written down because I want to graph with y'all on this one because people be freaking out about half points. Alright, good. Moving on up. W, that's easy. That's a whole one. So it's negative 1, negative 1 up to, so yeah, here. The next one, x prime, is at positive 2.50. So go over 1, 2, then 0.5. In the middle of 2 and 3 right here, stay at 0. Find middle, just guess what the middle is. It's about the middle to me. That'd be 2.5. And then for my y value is negative 0.5. So to the left, to the left a half basically. Don't go a full 1 to the left, half, and then go down negative 2. 1, 2. About right, chill. And this is W prime, X prime, Y prime. Y'all all right? Alright, so that's our basic dilations going from the origin. That should be easy for y'all. I do have to show you the other ones too. There are dilations we do on the back that we don't go from the origin. We dilate from a certain point. It's almost like when we rotated from a point that wasn't on the origin, and what else we did? We reflected from lines that wasn't the X, Y axis and stuff like that. You can still do dilations that way too. So let's do that real quick so I can be done with y'all. On the back, you're doing dilations not about the origin. Not much harder, just an extra step you have to take. And y'all be familiar with this step because, like I said, it's going to be similar to the step we took when we did rotations that weren't about the origin. You kind of mimic a X and Y axis. Alright, on the back. Let me give you steps at the top. Step 1, find the horizontal and vertical distance from your center point. You'll understand this when you see it. You've already done this before. You'll know what I'm talking about when you see it. And And then it says to one of your coordinate points of the pre-image. These steps are nothing new to y'all, believe me. You'll know once you see me do it. Step 2, multiply the vertical and horizontal distance time k times. So based on your scale factor. Then count that many units from the center, vertically and horizontally. Yeah. And then it says step 3, repeat step 1 and 2 for the leftover points. Let's do this. Down here, number 3 and 4, it says graph and label each figure in its image under the given dilation. Remember, these are dilations, not about the origin, so they're going to give us a point to dilate from. What's up? Huh? It shouldn't. I got my one from last year, unless the recording is written wrong. This is the same sheet from last year, and I got mine on the graph. Did you do something wrong? You messing up my video too, FYI. I wouldn't lie to you. The coordinates look exactly the same as the ones I printed from last. Let's try, Billy. How about that? Quadrilateral math with vertices. Yeah. Use point P as the center and use a scale factor of 3. Oh, you know what you're doing, Billy? You're probably trying to dilate from 0, 0. I told you not to go ahead of me. We're not dilating from 0, 0. We're dilating from this point they gave us, huh? Then your stuff shouldn't go off the graph there. Watch. I guarantee you. I know these original points don't go off the graph. They numbers 4 and less. M is at 4, 2. You gotta believe in me, man. A is at 0, 4. Yeah. Told you the back is different. Negative 2 up 2. And then H is at 2, 0. So M, A, T, H. Alright, this is my figure on the graph. The next thing I need to do is put the point on that they told me that's going to be my center of dilation. Center of dilation is going to be from 2, 5. 2 up, 1, 2, 3, 4, 5. This is going to be my center of dilation right here. This is my focus. I'm going to do exactly what I used to do, like I said, when we did the other ones too. From this center of dilation, I'm going to make an access for y'all. I want my orange marker. Where is it? Here's the orange highlighter. I know I'm going to make an access around this. Once again, it should all feel familiar. All stuff we've already done. I'm treating that as my origin for right now. Alright. So, out to the side here, and listen to me. Don't try to do nothing ahead of me because you're going to do something wrong. Out to the side, we're going to write the M-A-T-H, but don't write no points, and I'll tell you what points to write. M, we're going to do our parentheses. A, parentheses, T, parentheses, and H. Leave a little space in between on top of each one too. Like I said, I'm gonna be writing some stuff in. Alright. So, these points that we're pulling now, we're not pulling the original points that they gave us from up top here that we graphed. We're going to pull our points from based on where the center is. From here, we're going to say where M is based on that center. That's what they were telling you to do in step 1 up there. Find the horizontal and vertical distance from your center for each point. And y'all done this before. We did this with the rotations that weren't about the origin. So I want to know where M is based on this center of dilation. For me, from the center of dilation, I'm sorry, let me show you. M is 2 to the right and 3 down, right? I'm asking. 2 to the right, 3 down. That's 2, -3, yes? That's what I'm going to write down here for my M. 2, give a space, -3. Go up and find A. A is 2 to the left, 1 down. That's -2, -1, right? Welch, let's make sure you got the idea. Where's T at? Say it louder. So how does that look? -4, -3. Alright. And then Billy, give me the last one. H. Say it again. Say it, I hear you. 0, -5. Alright, so we're going to use these. And we're going to do a scale factor based off that. Scale factor is 3. So we multiply them by 3. Don't go ahead of me though. You don't know where to write this at. Do not write these answers over there in the box. These are not true locations. Times 3, times 3, times 3, times 3, times 3, times 3. Alright, this math for these. We're going to do it, but we're not putting them over here. These are not our actuals. So we're going to just write them above. So 2 times 3 for me is going to be 6. And then -3 times 3 is -9. I'm going to write that right above it. -2 times 3 is -6. -1 times 3 is -3. Putting that right there. -4 times 3 is -12. -3 times 3 is -9 right here. And then the last one, 0 times 3 is 3. -5 times 3, -15. Okay? From here, I'm going to use these points. Oh, why y'all ain't catch me? Y'all ain't see the mistake I made? Thank you. 0 times 3 is 0. Y'all let me say 3 and y'all just roll with it. Y'all got to correct these mistakes. Everybody except for 10 is allowed to correct me. Alright. From using these coordinates now. Using these coordinates we just got, we're going to go back to the graph and we're going to graph these points from the center. Not from the center that we created, 2, 5. So from 2, 5, I'm going to use the point 6, -9 to find where M prime should be at. So from this point right here, I'm going to move to the right 1, 2, 3, 4, 5, 6. And then I'm going to go down -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here. Make that M prime. And then the next one that I wrote for A was -6, -3. Go back to that center point. Go over to the left. 1, 2, 3, 4, 5, 6. Then I'm going down -3. So 1, 2, 3. I'm sorry, sir. If you think I made a mistake, say something. But the next one is T. That's negative 12, negative 9. So I'm going to the left 12 and then down 9. If y'all know how these graphs are counted, you could cheat it a little bit. I'm 2 to the right now, and I know this way counts 10, so I'm going to just shoot all the way over. I know that's 12. But if you don't know, just count it out. So I went over to the left 12, and I'm going down 1, 2, 3, 4, 5, 6, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here. I think I'm in the right spot. Yeah, it looks good. Somebody grab the door real quick. See who that is. Sorry about that, Jorge. I know you're doing your notes. And then the last one is going to be 0, negative 15. So you stay at 0 left and right. You don't move. And you're going down 15. To be honest with you, too, that's going to be all the way at the bottom. Because it's 1, 2, 3, 4, 5 right here. And you know it's 10 down here. So it's going to be here. And look what happened, Billy. We're still on the graph. I thought you said we weren't going to be on the graph. Then connect. What's up? Alright. So after you do that, the very last thing you need to do, and it should be obvious for y'all, this is what we did when we did, like I said, the rotations. I keep reminding you because it's kind of the same process, except you're just not rotating. Last thing you need to do is get your actual points from 0, 0. That's what you want right here for your primes. You want your actuals from the original origin. The last thing you do, you go back to your original origin right here, and we want to know our points actually where they are from 0, 0. So actuals from 0, 0, M prime is going to be at positive 8, negative 4. I could just show you down here. A is going to be at negative 4 up 2, positive 2. T is going to be at negative 10, negative 4. And H is going to be at 2, negative 10. That is doing a dilation from a point not about the origin. Do one more and I'm done with you. Let's do it fast too. I want to give you a lot of time to work. Got 40 minutes left. That's a decent amount of time. Quadrilateral ABC, D with vertices. Yeah. Use the point 3, negative 4 as your center point with a scale factor of 1/2. Alright. Graphing that real quick. 10, 10. Way up here. 5, 8. 5 should be in the middle. 1, 2, 3, 4, 5. Negative 6. Negative 2. And then 1, negative 7. Alright. A, B, C, D. my figure on the graph, I need to put my center point in, which is 3 for -4. So 3 down 1, 2, 3, 4. Alright, here. Okay, 1, 2, 3, 4. Yeah. Where everything gonna be based off of right now at this point. So we're gonna have A, B, C, and D. Tylee, help me out. From that center, where's point A gonna be? No. A is right here. From the center, where is it? I see. Who ain't confused? Yes, sir. Kiara, is that it? A. I think you counted the opposite way. You gotta go to the right first, then go up. Seven and 14. There we go. I think I want him to do this one, y'all. Give me B. Yeah. Two and what?
12.
Yeah. 2 and 12. I'm going to do C now. -9 and 2. And then my last one. Try it one more time. Move to the left first. -2, -3. Alright, those are our points from my center. Appreciate that. Now we just need to multiply them times a half. That's our scale factor. Remember though, since we're going from point not on the origin, we are not writing these calculations that we get over there. These are not going to be our actuals. These are just from our center point. We don't do actuals to the very end. Some of these will be decimals. Don't panic. 7 times 1 is 7 divided by 2. That's going to be 3.5. So 3.5. And then on the other side, 14 times 1 divided by 2, that'll be 7. The next one, obviously, 2 times 1 divided by 2, 1. And then 12 times 1 divided by 2 is 6, so 1/6. The next one, negative 9 times 1 divided by 2, that's negative 4.5. 2 times 1 divided by 2 is 1. And then our last one, negative 2 times 1 divided by 2 is negative 1. And then negative 3 times 1 divided by 2, you're going to get negative 1.5. If you don't believe me, put it in the calculator. Alright, so those are our points we got to count from our center. Let's do A first. From the center, we're going to the right 3.5, up 7. To the right, let me do this with you. 1, 2, 3, go over a half, then go up 7. 1, 2, 3, 4, 5, 6, 7. You'll land about right here. Next one, 1/6. Go over 1, go up 1, 2, 3, 4, 5, 6. So it's A prime, B prime. We're going to have a label. Next one, go negative 4.5 to the left, then up 1. Negative 1, 2, 3, 4.5, up 1. C prime. And then the last one is negative 1, negative 1.5. So to the left, negative 1, then down, negative 1.5. And then connect. You'll know you did it right if your shapes look similar. And then we gotta read our actuals. That's what I want you to do, Torres. As you connect. Torres, whenever you're ready, give me the actuals. These are from 0, 0 that we're going to write in. This might still be connected. Torres, you ready? Say it again.
6, 3.
Try one more time. You close. Oh, Rodriguez, what's up?
6.5.
Yeah, 6.53. Remember, that was one of our halves that we did. Well, Rodriguez, you finished then. Yep, B prime. 4, 2. Negative 1.5, negative 3. Good. Try that one again. Hold on. You might be looking at I think you're looking at the original D. Look at D prime, and I ain't even put a prime notation on mine. My bad. Yeah, 2, negative 5.5. I'm bad. I didn't know I wasn't showing y'all that. So. Alright, kiddos. Oops, didn't mean to do that. Just trying to stop the video.